In 12.5, equations of lines and planes, we're going to start out with a problem that's like number 3. Find a vector equation and parametric equations for the line through the point 0, 14, negative 10. And parallel to the line, x equals negative 1 plus 2t, y equals 6 minus 3t, and z equals 3 plus 9t. So first of all, the vector equation form of a line is r is equal to r naught plus t times v. So notice we have vector r sub naught, vector v. T is a parameter, and you can think of that as a scalar. And so this is just the general form. We're given this point here, which means that we can just go ahead and write the vector r sub naught. Now, vector r sub naught is not just the point, but it turns out it is the vector that's from the origin to a point on the line. So we can just basically take any point on that line and represent it as a vector, and that becomes r sub naught. So that was pretty easy. And then the other thing we need to write the vector equation of a line is the t is something that we just put in here with this form is the v. And so here we're not actually directly given v, but we can find it from this information that says it's parallel to the line, and then we're given the parametric equations for that line. So to extract that v, let's actually look at that a little bit more closely because we're just starting out. So for the parallel line, we're given this parametric representation. And so actually using this in expanded form, the vector equation line, what that is, the vector r is x, y, z in component form. R sub 0 is x sub 1, y sub 1, z sub 1. Plus, and then we have the parameter t, and then v is kind of just given the generic ABC for factoring out the t is how you can kind of think of this, or just having the vector v there. So with that parametric form, matching this up, the x equals negative 1 plus 2t. Negative 1 is x sub 1. T is on the outside here, and then a is equal to 2. So continuing down the line here, y is equal to, and then we have 6 is our y sub 1, our b is negative 3, and then finally for z we have our 3, and we have our c equals 9. So again, we're kind of going back and forth with this vector equation of a line that then we can see for a line parallel to v, that's exactly where v is parallel to our line. So if we're given a line parallel to our line, its v can be the same. We can use the same one because they're parallel. So we're going to use this right here as our v for our line. I'll just write a note here, parallel, so can use the same. Now there's other vectors parallel to this, so that's why I would say we can use this. There's others that exist, but might as well just use that one. So then we have for our, one way to write for our line, just to be clear here, is we can write it, oops, but not r sub naught. What we can do here is write this with r sub naught, which is 0, 14, negative 10, and then plus t, and then our v that we just found, 2, negative 3, 9, and that is a way to write the vector equation line. And then it also asks for the parametric equations, so we're going to do kind of like we were just doing before, except going forward, in that we can just write this r as x, y, z. Just write that reminder down here. And then breaking it up into the components. So what we'll have is x is equal to, we have a 0 here, and so it's just going to be 2t. y is equal to 14 minus 3t, and then finally z is equal to negative 10 plus 9t. I'll box that off and check it. Make sure I didn't make any mistakes. And it looks good.